Hi, my name's Anthony. I work for Wolfram Research Europe, and I'm a technical content developer there. And what I'm going to be talking about today is machine learning. So basically, how you can use machine learning algorithms in Mathematica to make your life easier, essentially. Okay, I think that's working, right? So nice to meet you, everyone. I'm Anthony Zupnik, technical content developer at Wolfram Research Europe. And what I'm going to talk to you about is machine learning in Mathematica. So I guess what are we talking about when we're talking about machine learning? We're talking about having your machine interpret your data with limited direction. So basically, you can just feed in pictures or sounds or text or whatever, and then classify your data in some way by saying it is a certain thing. And then leave the algorithm to do it for you. So that's generally fundamentally what machine learning algorithms do. And examples of this, which I'll show you many examples because I think inspiring you potentially to create your own examples and see the possibilities is the most interesting thing that I can do for you. So examples that are typically given are spam detection, fraud detection, so maybe a forged signature or something like that, digit recognition, customer satisfaction, et cetera, et cetera, et cetera. So there's plenty of facial recognition and things like that are also quite interesting. They can be a bit more complicated, but all of this can be done with machine learning if you have the right tools. So the idea is that you can just feed in as much data as you like. And as I said, you assign values and allow the pre-built algorithms to do the work for you. And on top of this, there are standard machine learning algorithms which exist in the world, which I will talk about. You don't even have to worry about that. So you don't need to be some kind of machine learning expert to be able to understand the fundamental principles. Obviously, if you understand machine learning, then you may think that the automatic method selection isn't completely working out for you. You may think that you know better, which you may do, and then you'll be able to select the method yourself. So let's have a look at a basic example. I guess in some ways I don't need to show it, but it's in my talk now, so I will mention it. So very simply, so here we've made some classification. We say we've got a picture of cats and dogs, and we say the cat is grey. My cat is fast, dog is scary, the big dog with pictures of cats and dogs. So this is symbolic as well because we have these images, I suppose, that we're classifying with. And so we just use this classify function, we wrap all the information around, and then we say, okay, what if I put the text in nice cat, what are we talking about here? Or what a dog, what are we talking about here? And I did not run that. So it will give me a nice picture of a cat, although it's very small. I'll make it a little bit bigger, and a dog. So this is a very fundamental principle of how it would work. It tells you what method was used. So the classify function says it is used, automatically selected, the Markov method, and it says there are two number of classes using text, and it tells us the number of examples as well in this little object, which is quite nice. So a slightly bigger example. Which is very interesting is let's say some numbers. So we have some handwritten digits here. There are 100 numbers here, and we said 2 is 2, 5 is 5, etc., etc., etc. We can classify that, and then we feed it some new numbers. So here is decided logistic regression. Number of classes is 10 because we have the numbers 0 to 9. And what do we get out? We get 0, 1, 2, 3, 4, 1, 4, 7, 8, 9. So almost right. The 1 has been identified as a 5. I could cheat, I suppose. I think if I run this again, it might work a little bit better. Apparently not. But this is obviously because we only have 100 numbers in this example. You're going to run into issues with specific examples potentially. So when you're starting to talk about 1,000 numbers or something like that, it's a lot better. So something that John touched upon again is built-in classifiers. So just to make things easier for you, especially when you're kickstarting, What about languages? So we have, if we just put classify, then language is the language built in classify, and then we can just feed it in data as we would normally with classify. And here, well, I've already got the results right here, but it calls the Wolfram server. Depending on the internet connection, obviously, show you how fast it is. So it's downloading the classifier directly from our servers, and then it's processing the information. And then it's telling us these languages are English, French, Spanish, German, Chinese, Arabic, Ukrainian, and Greek. Obviously, it can probably be a bit easier to classify a language which has a specific character set, but at least with English, French, and Spanish, they are the same. So that's pretty cool. And then we can even find out probabilities. So we can just list the top probabilities. So we have this language string, which is actually a mixture of English and French. So the house is blue and la maison est bleue, or yep. And use top probabilities. Sorry about my accent. I'm sure that was not so good. And so I run top probabilities. It says 50% English and less 42% to French. So this is really cool. You can use probabilities or top probabilities, and there's a few other examples that you can do to get more information out of your classifier, because probability can be important. Because obviously here, if we really wanted a specific classification, it's, we don't know what the threshold is or anything like that on that classification. So sentiment analysis as well. So we can say something like, I love this movie, so depressed today, my phone broke again. Or let's go for this talk is amazing. And we've got positive, negative, negative, positive, which sounds about right. So again, this is what we call from our, with our classify function, internal servers, which is great. Name, gender, so again, very similarly, we can feed in names from all cultures, I think, and then it will determine whether or not it's male and female. So these things can be useful so that when you integrate them, you don't have to, into your own programs, you don't have to do this yourself, because these are common things that people may be interested in. And we've got this classify spam as well. So if you wanted to integrate some kind of spam handling, we have this spam email that was taken. And I don't know what specifically it looks for in a spam email, but it's determined that this is indeed a spam email. So additional options for classify. So class priors is one of the more useful options that you can apply to classify. So let's say we have some data. We have just these numbers, 1, 2, 3, 4, and 6 are equal to true. 5 is equal to false. And then we want to classify it. We've made a classifier with 2 members. And now we want to classify 5. So we know from looking at this classification that it should be false, because we said 5 is false. But because we have this top-heavy set of data, where we've got more truths than false, we may need to add class priors to it, where we essentially state that prior to the classification, there is a given probability of it being true or false in one of the members. So here we say, okay, we can have a look at the probabilities, using probabilities as an option of being true or false of these 2 numbers. And it says that false was 34% and true was 65%. But now, if we say class priors and we assign class priors, false is 50% chance and true is 50% chance, then what we actually get is that it returns false, as we would have expected by just looking at the data directly. Because now we're not looking at the specific number of results, we're treating all data equally, essentially. And we can integrate, and now we have a look at the probabilities, and the probability is 60% for false and 40% true. Equally, we can, if we want to classify with class priors directly, so this was done after the classification, we can do it before we classify or after classify, depending on what we want. So yeah, I'll just run through this again, and it's exactly the same thing. It gives us the same thing. Intermediate threshold is a useful option if you're integrating your classifier, and you only want at a certain % confidence level that your classified number or object is correct. So here we have some training set. We classify it. We find the probabilities. So here for 2.5, the probability is 61% at B. And we know that the most probable class is B. But what we can do is we can put an intermediate indeterminate threshold at 90% confidence level, essentially, whether or not this will succeed or not. And because we know that it was 61%, it's not going to work. Now, one of the most useful things, again, if you know about machine learning, again, as I say, you just feed in the data yourself. If you don't know anything about machine learning and you don't want to do any research, let Mathematica do the work for you. But there is the option method, which allows you to turn off the automatic method selection and choose the method yourself. So the current machine learning methods that we've got at the moment that will be released, presumably with 10, as it's not released yet, I don't think anything else is planned to be included yet, is logistic regression, Markov, naive Bayes, nearest neighbors, neural network, random forest, and the support vector machine. So I can give a training set, and then I can specifically say the method goes to, in this case, logistic regression, and I can say method goes to random forest in this case as well, and then I can plot the results. Plot the results as a function of probability and see how of a given value. So here we're choosing A. What is the probability that it is a given number between 0 and 8? And we can see that there is actually a high difference between using logistic and random forest, which you would expect. Utility functions, so this is something that you should be aware of that exists as well. So if you want to weight a penalty, I suppose, in a classification, here we say we've got, like we could say people are healthy or diseased, I suppose. We do a classification at 2.5, what is the probability of someone being diseased or healthy? And it's in this case, it's 58% healthy, 41% diseased. But these things are quite close together. So what we can do is, with a utility function, we can add a penalty where if it's healthy, it's fine. But if it's close to disease, then we add a penalty basically for diseased. And what this will do is it will change the classification to diseased. And again, like with class priors, you can put utility function either before you classify or after. Nominal values. So here we have some numbers, and this is something that you should be aware of when you do classifications. We're saying 1, 1 to blue, 2, 2 to blue, 3, 3 to red, and 4, 4 to red. And we do a classification normally, and what we'll find is that if we have a look at the feature types, so what features we're interested in within these classifications, we go to feature types, and it says the features that we're looking at are numerical. But what we're going to say is these are nominal values, so categories. So what happens with the classification is if we put in 5, 5 probabilities, it will say it's almost guaranteed to be 1 because it's using numerical features. Whereas if we define nominal variables and we run this again, we can see the features are now nominal. And we do 5, 5, and it says it's equal probability of blue or red. So final example of options is a validation set. So a validation set against your training set. So here we've got this machine learning example of Fisher iris data. We'll classify it. And it's given logistic regression. So with logistic regression, we can get the L2 regularization parameter. And here it says it's 0.01. Now, if we have a validation set, and we apply the validation set at the moment of classification, we can change these internal parameters, and one of them is L2 regularization, and you can see that the value has changed. Okay. So another function that exists as a complement, I would say, to classify is predict. So here we have, as a basic example again, we have 1 goes to 1.3, 2 goes to et cetera, and then we can create a predict machine learning algorithm. It basically uses the same stuff, but now when we try and predict what value 1.5 has, it won't try and lump it into a category. It will try and estimate a value for you. So here we'll estimate the value 2.1, as opposed to before it would be saying 1.3, 2.4, 6.4, or 10.1. So it tries to give an estimate because you want a numerical answer like this. And then we can see a distribution. So if we can get the distribution of a given number. So here we've put 1.5 distribution, normal distribution with values, and then we can plot the distribution like we normally would in Mathematica and see what the distribution actually looks like for these values. And a bigger example of this, although it's actually shorter, I would say, is we can feed in numbers. So we can feed in images. So here we're feeding in objects and defining basically the area, and we want to classify this. And then we want to feed in new objects and identify what the actual areas are of these new objects, and it will estimate them for us as well. So this is how you can use it in a really interesting way, and you don't have to do too much image processing there. I mean, here the squares are the same size, which makes classification a bit easier because we're not giving it too much direction. Okay, so now I've taught you about the basics. I won't say that they were boring, but I would say that they were less interesting as what I'm about to show you now. So let's try and make this a little bit more exciting. So I made this function to scrape Amazon reviews off the Amazon website. So I got all sorts of reviews. I got 10,000 reviews, and basically, just so you can see the function that it exists, I'm not making it up, I guess. I put them into text files, and then I imported them in and made a classify. So if I import the data in now, I do a classification. I did make a slight mistake here. So on Amazon, people can give 1 to 5-star ratings. So that's five classes that actually exist. But what you'll see here is there's 6 because I didn't process my information properly. But we don't care about that. It's not very important. So here we've got 11,521 examples that I actually scraped. I made a function so that I can feed in a review. So I would ask someone in the audience, put their hand up or shout out a movie, maybe not one of the most recent ones, but one in the last couple. It doesn't really matter. Just Dash Boat. Is that going to be in Amazon? I hope so. I've never heard of it. So okay, I'll go to Amazon. Okay, so you said Dash Boat. Yep. Yep. D-A-S space boat. Okay. Oh. Okay. Oh, okay. Great. Well, I'm sure it's a thrilling film. It does have 4.5-star reviews, so maybe I'll watch that. Okay, so let's get this review. We'll grab this one. We'll put this in my little function, and let's see. 5 stars. So it's estimated 5 stars with a probability of 95%. Okay, that works. So great. Maybe we'll try some of the negative ones. Now, the thing is, with a lot of these popular movies, what you'll find is that they're very heavily weighted favorably. So we've got a lot of 5-star reviews, but let's try and get one of these 2 stars, and this is where things can get a little bit hairy. It says 5 stars again. That's not fantastic. let's go for this one. This one's got this. Maybe this one should be okay. I have faith in this one working. There we go. 3 stars, not too bad, with a relatively high probability, and it was 2, not too bad, I think. So yeah, it's very interesting that you can do this, and if I fed in more examples, I only put 11,000 examples in, which isn't very much. Okay, cuisines. So this is something that my colleague made, Martin John Hadley, and I have to mention his name. Please, could someone tell me 3 ingredients or something like that for a recipe that they have? Doesn't really matter what 3 ingredients they are.
Coconut milk, basil leaf.
I'm going to go for, how do you spell?
Coconut.
That's coconut. I'm going to go basil, because you said basil, and I don't know what that is. How about another ingredient?
Let's say pepper.
Pepper. Okay. Let's define the cuisine. Okay, we're going to go with Southeast Asian. Is that correct?
Maybe, yeah.
There we go. I'm going to take that as a win right there. But it's really cool that you can make these dynamic objects which do this. So okay, so those are some text examples. Numeric. This one's a little bit less interesting, but it's cool to show. So here we get some data from the Titanic. We have a look at what the data looks like. So it says, what class they were, whether or not what age they were, and whether what their gender was, and whether they lived or died. Then we can classify here. We've chosen to classify by logistic regression. And then we say, what was the probability of new data, so a female in 3rd class, the age of 10, of survival? It says 84%. And then we can plot based on, Okay, well, that worked like very, very recently. So that was unfortunate, but usually what you would see is a plot. Imagine that you see a plot which shows, based on your age and gender, how your survival rating based on this thing. Now this is my most exciting one. Well, okay, maybe it's not my most exciting, but let's try this. I hope it works. So here's me, and I hope this works. Okay, so we got some images here, the flags. I'm going to hold them up and see if it identifies properly what the flag is. Okay, that's good. Let's go for Hungary. There we go. That's success. Keep going. We'll go for Germany. I've got to go for Germany here. Germany, Brazil, because that's where the World Cup is this year. And then finally Cyprus, because I am half Cypriot. So so that's got to support my country. Yes, sure. I don't know if the classification will work in this case, because I think I made it so that it wouldn't, but it might do. Yeah, see. Look, I even have an arrow here, which tells me, yeah. So, when I did the classification, if I'd made it more specific, then that would work. But I wanted it to work only at a given level. And then numbers. So this is really cool, a very short demonstration. I can write in numbers here, and then it can classify for me what the actual number is. And that's very cool. But that didn't work. I'm not very good at drawing. So unfortunately, I've run out of time. The sound example was cool, but just so you know, the sound does exist. You can do sound processing in this way. But yes, thank you very much for listening. I hope you enjoyed the talk.